Good day, class. Today we're going to discuss about Module 5, Measures of Variability. I am your professor, Dr. Nikli Alcaratira. For the objectives of the module, we have two objectives. Number one is to explain how the standard deviation of a sample differs from the standard deviation of a population and why they differ. Number two is to understand the illustrative examples, do the practice problems, and understand the solution. For the introduction, let us try to discuss variability. Variability specifies how far apart the scores are spread, and it measures or quantifies the extent of dispersion. Three measures of variability are commonly used in the behavioral science. First, the range, the standard deviation, and the variance. Let us try to discuss each one of them. For the range is defined as the difference between the highest and the lowest scores in the distribution of equation. Range is highest score minus lowest score. The range is easy to calculate but gives us only relatively crude measure of dispersion because the range really measures the spread of only the extreme scores and not the spread of any scores in between. For the practice problem, we have to calculate the range for the following distributions: A distribution, letter B distribution, C, and letter D. For the solution for this distribution, for the computation of the range, we have 10 as the highest score and 2 as the lowest for distribution letter A, and the range is 8. For distribution B, the highest score is 28 and the lowest is 12, and you have the range of 16. For the distribution letter C, the range is 100, the highest score is 118 and the lowest is 101, which gives us a range of 14. For distribution letter D, the range is the highest score is 2.3 and the lowest is 1.2, which gives us a range of 1.1. Now here we have the deviation score discussion, and deviation tells us how far away the range scores is from the mean of its distribution. So here is the formula for the deviation score. So we have your table 5, calculating deviation scores. We have here the first column, the second column, and the right side gives us the calculation of the mean. So here you have the scores, 2, 4, 6, 8, 10, and the calculation for the deviation score is the score minus the mean. Okay, so how are you going to compute for the mean? You have to have the total or the summation of the score, which is 30. You add all of this, and your total number of cases is 5. 1, 2, 3, 4, 5. You have 5 cases. So 30 divided by 5 is 6. Okay, so, and then you replace the computation or the formula here. The score is 2. The mean is 6. So 2 minus 6 is equals negative 4. For the explanation of how these scores are placed in a continuous distribution, let us try to have figure 4.4. So figure 4.4 shows us the row score and the deviation score. So we have here 2, 4, 6, 8, 10 as the row score, and the deviation score computed as the score minus the mean. So for a score of 2, the deviation score is negative 4, which means that the score of 2 is 4 unit below the mean. For the score of 4, it means that 4 is 2 unit below the mean, as the score of 8 is 2 unit above the mean, and the score of 10 is 4 unit above the mean. So next you have the computation for the population score. So you have here the sigma symbol, which means it is the symbol for standard deviation for population. And here is the formula for the standard deviation of a population of set scores minus the deviation method. And you have here where sum of squares population is equivalent to the summation of close in parentheses the score minus the population squared. Okay, so you have your table 4.6, the calculation of the standard deviation of the population of set scores by the deviation method. So you have here the set of scores symboled as X. These are the scores, the spread of scores. And here are the formula for the score minus the population mean. And you have here the third column, which is the close in parentheses, the score minus the population mean squared. And you have here the formula for the population mean summation of the scores over the number of cases replaced by numbers. 25 divided by 5 equals to 5. And then you have here the standard score computation. Okay, so the next table is the formula for the standard deviation for sample. So here is the symbol for standard deviation for sample, and here is the formula. Okay. So next would be table 4.7, the calculation of the standard deviation of sample score by the deviation method. Again, you have three columns, and on the right side, you have the calculation of the mean and the standard score for samples. So you have here the set of scores, the computation or the answers for the score minus the mean. Okay, formula, and you have here close in parenthesis the score minus the mean, so the score minus the mean squared. Okay, so here's the formula for the mean and the formula for the standard deviation for sample. Calculating the standard deviation of a sample by the row score method. So it is algebraically shown. Here is the formula. So the sum of squares equivalent to the summation of the score squared, and you have here close minus the summation, close in parentheses, summation of the score squared over n. So these are the sum of squares. So here is table 4.8. It shows us the calculation. Here on the right side shows us the calculation of the mean and the standard deviation for samples. So the table 4.6 is titled Calculation of the Standard Deviation with Use of Deviation Scores when the mean is not a whole number. No, so which means the mean is not a whole number, it is decimal points. Okay, so you can just take a look at the table and the three columns for the table. Okay, so next we have the properties of the standard deviation. So the standard deviation has many important characteristics. It gives us the measure of dispersion, and then it is sensitive to each of the score in the distribution. Okay, like the mean, the standard deviation is stable with regard to sampling fluctuations. Okay, so 4.9 table is the calculation of standard deviation by row score method. So you have here the row scores, and you have here the summation of the score or the total of the row scores, and the total number of cases is 8. So you have here the squared scores. Ayan, no? Here are the squared scores. And the calculation of the sum of squares is here, and the calculation of the standard deviation, okay, is here. Okay, so next, for the practice exercises, you have to log in our US Moodle account, or I can just load your worksheets on a particular platform chosen by our university. Okay, so that would be all for today. You can just chat me or text me for further clarification if you don't understand the lesson. So thank you very much and have a great day.